Silicone obviously is very important for the medical device industry and industry in general, but why is that? What is it about the material itself that makes it special and unique? Our next speaker is going to be addressing these questions by doing a deep dive on the technology behind the materials so we can understand this better. Our next speaker is Jarno Burkhardt. Jarno is the general manager of our Stein and Rhein facility, and he is going to share with us more about material technology. Jarno, welcome to the stage, and what can we expect from your talk today?
Hello Daniel, nice to be here. I'm going to talk about silicone material and the related processability as an introduction of the technology.
And we're already getting questions on sustainability, so you get bonus points if you connect anything with sustainability in terms of what you're talking about.
Exactly, right.
All right, good luck.
Thank you very much.
Thank you.
So, hello everyone, my name is Jarno Burkhardt. I work for Trelleborg since 23 years by now. I'm based in Stein am Rhein, the facility you get to go on a virtual tour later on. I hope you enjoy it, as a general manager. But in this session, I'm going to talk about silicone as a material and the related processability. So, number one question then, what is silicone and where does it come from? Silicone as a chemical element is part of the periodic table. Not to confuse in this case with silicone as a material, it's written without E, being called silicone. It's classified as non-metal, but it is metalloid. That means it is like a semi-metal. It carries metal inside, but it's not displaying them. 1/3 of Earth's crust consists of silicone. So it's the second most abundant element of the surface after oxygen. However, it does not often exist in its natural state or pure form. It's typically found as a compound in combination with oxygen. So this compound product we would call silicone dioxide or silica. Examples, I guess everyone knows, being sand or quartz. Silicone then is obtained through the chemical reduction of silica at high temperature and then through an upstream process. And this is where all the chemical technology lays in. The silicone metal is transformed into siloxane prepolymer. This siloxane is known commonly as PDMS, and PDMS is an optical clear, inert and non-toxic fluid. PDMS basically is the precursor polymer for all type of silicone. And here we come back to the E at the end, including oils, chalks, greases and rubbers. And silicone rubber, BMQ, is a very specialized elastomer with extreme and unique characteristics and related performance. And this is basically the main focus around silicone material of our processes. But why to choose silicone rubber? It comes with an outstanding temperature resistance. It goes up to 315 degrees Celsius and at times even exceed, but also covers low temperature down to minus 110 degrees Celsius. It's extreme weather resistant, flame retardant, chemical and media resistant, and also radiation resistant, what means you can sterilize it in any typical way of sterilization. It comes in a bright variety. We can also tailor the material with different modification, customer-specific additives to increase certain performance properties. And we can also add a wide range of colors if needed. The material is extremely reliable. It's inert, biocompatible, purely inorganic, that makes it the perfect choice for medical application. Silicone is ideal for medical applications. If we look at this table, we do not so much focus at silicone that is curing at room temperature. This is basically more the material you would use in your houses or to seal applications in your bathroom. We do focus more on high temperature curing materials, such as liquid silicone rubber, LSR, or solid silicone, named HTV or HCR. So what are the difference between these two? LSR, as the name suggests, is the liquid form of silicone rubber. It has a very low modular weight, shorter chain length, what enables really a perfect flow behavior to fill really complex cavities due to also lower viscosity. It's highly purities because it's platinum catalyzed. Typically the material is supplied in two components, so there's an A component and a B component, which then being merged together at the injection process. The advantages of liquid silicone rubber: it has very fast cycle times. It gives a great opportunity for two or multi-component parts, so to be added with thermoplastic or metal or a combination of both. Typically there are no secondary finishing processes needed, and it also allows micro miniature molding, what is really ideal for wearables. Extreme geometries to the excellent material behaviors are possible, and it's really economical because we can generate a high volume output. And a Trelleborg development in the area of rapid prototyping and small series production, the iCAST, is possible with LSR. So iCAST is really closing the gap between a fast prototype and a pre-series or a small series batch out of standard LSR material in superior geometries for our customers. A comparison between injection molding and the iCAST process is shown at this slide. So the part quantities typically are low to mid-sized production batches. The surface resolution and the quality in general is already medium to high quality. There are no pre-investments in tool or machinery nor equipment needed, and we do use standard LSA grades. We do not manipulate them, there are no additives, there are no fillers. So these LSR materials are, as you have listed for your application, they come with the certification, this is standard material. And the turnaround times for these parts can be days, maybe weeks, based on the complexity and the quantity, but it's vastly shorter than making a steel tool and setting up an injection molding run. So what is then HCR, HTV? Spelled out, high consistency or high temperature curing, so the solid form of silicone rubber. It's vulcanized with either peroxide or platinum catalysts. It comes with an increased loading of silica. It has longer change, so also a higher modular weight, a higher viscosity, and the advantages of HCR, there are much more opportunities to customize it, to make customer specific modification, to tailor, to blend it according specific application needs. Typically it comes with a lower cost per kilo in comparison, and also the tooling costs are lower and have a shorter turnaround time because the surface tolerance requirements are not that extreme as in liquid material. Multiple catalyst options are available, and it's suitable for more manufacturing processes aside injection molding, also compression or transfer molding. There are extrusion opportunities, manufacturing processes like calendering, and a wide range of hand fabrication opportunities are possible. To summarize, silicone rubber within Trelleborg, we do have an in-depth experience and knowledge of silicone material for medical application. And this covers high consistency as well as the liquid form of silicone. Our capabilities cover any type of manufacturing process, and it's there in a global footprint with specialized sites all around the globe. Trelleborg material specialists can really help you in designing, setting up manufacturing, the compliance and the validation aspects of silicone parts. Trelleborg is an outstanding partner for medical silicone solutions. Thank you very much.
Jarno, thank you so much for that presentation. That was fantastic.
Thank you.
Yeah, so we're going to go to the audience questions now. First question that we have is, if I don't know which type of silicone to use and which grade to choose, can Trelleborg assist me in selecting the most suitable and cost-effective option?
Yes, of course, definitely. This is basically one of our core competencies. With local teams, local presence, in local language, we can really support our customers by understanding the application, the media, the functionality of the part to recommend the right grade, type, or even modify, in some cases, the material to a perfect fit for the right application function for our customers.
Great. This is a material question. So what are the two best and two worst thermoplastics to bond in a 2K process with injection molding?
Right. As always, it depends a bit on the geometry and the media and the application, but generally speaking, PBT, PA are probably more preferred. Then I would not exclude anything in general. It would really depend on the application and the functionality.
Great. The classic engineering answer is always, it depends. So there we go. So you mentioned that the next question is, does Trelleborg have silicone experience in all of the industries that you mentioned?
Definitely, yes. So everything we are talking about, we are demonstrating are based on experiences and examples. So this is not science-based, this is really based on experience. In some of the cases, we're looking back to more than 40 years of experience. So it's really fact-based what we are talking about.
And at 40 years, that really is at the earliest foundations of LSR molding.
Yes,
so it's very interesting, the
really
history
pioneering,
there.
yeah.
What are the instances where you wouldn't recommend silicone as a material choice?
So typically and generally speaking, if the application is in contact with oil, benzene, gasoline type of media or grease, silicone would probably not be the preferred material. But again, it depends. But generally, our material experts would more likely recommend other type of materials.
Okay. What is the primary way to modify the Shore-A hardness of a typical silicone?
Again, it depends because you can do it right at the material mixing, especially at the solid silicone. But generally speaking, you would impact the precise shore hardness by a secondary post-curing process or by the cycle time itself.
Very good. And our last question is there a silicon type that is lower on silicone oil?
There are specialized grades being lower on silicone oil, and we can recommend the right one then really based on the application, yes.
And as always,
it depends.
There we go. Well, Jarno, thank you so much for joining us for that. That was fantastic.
Thank you for having me.
Thank you.